Hey, so today we're going to get back to working with experimental probability. Okay, so I just want to remind you of yesterday's video. And remember that the probability of success we can calculate by the number of successful outcomes divided by the number of total trials. Okay? So in our activity yesterday, right, we calculated the probability of getting a green marble, right, when there was 2 green marbles in the bag and 1 blue. Okay? So I want to remind you from yesterday's activity, if you take your sheet out and have a look at it, the more trials you did, the closer the probability got to 66%, right? So more trials, the closer the probability got to 66%, which is 2/3, because 2 out of the 3 marbles in the bag were green, right? So the probability should be 66%, and the more and more trials that we did, the closer our number got to 66. Okay? So that means the more trials makes our experimental probability more accurate. Okay? So more trials, better experimental probability. Okay? So now let's look at working with experimental probability. Okay? So we roll a die 10 times and the number 6 appears twice. So we roll a die 10 times and the number 6 appears twice. What's the experimental probability of rolling a 6? Well, the total number of outcomes, so we'll call that the probability of rolling a 6. The total number of outcomes was 10, because I rolled it 10 times, and the number of successful outcomes was 2, because the 6 rolled twice. So we can reduce that to 1/5. Okay? Now, what's the experimental probability of not rolling a 6? Well, that's all the other stuff, right? So if we got 2 6s, we rolled 10 times, it means that we got 8 not 6s, right? Or unsuccessful attempts. So that means the probability of not a 6, right, was the total number of outcomes was 10 again. But in this case, the number of successful trials was 8, because 8 of the rolls were not 6. Okay? So again, we can reduce that to 4/5. Or you can just put that in your calculator. You can put 2/10 in your calculator and tell me that the answer is 0.2. That's fine as well. And here your answer would be 0.8. Okay? That's fine. I want you to notice something though. See how these two add up to 1? That's because I know that I'm either going to roll a 6 or I'm not going to roll a 6. That's 100%. That's why those two add up to 1. Okay? Let's look at one more example. So this is an actual real life example. So scientists and researchers actually do this kind of stuff. So in a pond, 20 fish were tagged in order so that they can track their population, right? So in a pond, they catch 20 fish and they tag them all with either microchips or physical plastic tags. Okay? A year later, so 20 fish are tagged. A year later, 15 fish are caught and 3 of them had tags on them. Okay? So, what's the experimental probability of a fish being tagged? Well, our experiment was we caught 15 fish and 3 of them were tagged, right? So the probability of, I'll call it T for tagged, so the probability of a fish being tagged is there were 15 total trials, right? And 3 of them happen to be tagged, right? So 3 divided by 15 on your calculator is 0.2. So 0.2. Okay, that's the probability of a fish being tagged. Or remember, we can also call that 20%. Right? I can answer with any one of these things: fractions, decimals, percents. Now, how many fish may be in the lake? Okay, so we're going to use our probability here and the fact that we tagged 20 fish at the beginning to figure out how many fish there may be in the lake. All right? So the probability of a fish being tagged is 20%. So 0.2, right? That's the probability of a fish being tagged. Now, that needs to be the same as the probability that we tagged that fish, right? So the probability, now remember, if we tag 20 fish, those are successful outcomes, right? And the total number of fish is X, because that's what I don't know, okay? So the probability that a fish is tagged is 3/15 in this experiment, And in this experiment, it's 20 out of all the total fish. Okay? So 3 out of 15 were tagged, 20 out of my total were tagged. Okay? So now all we have to do is get rid of that x. Okay? Now I need you guys to remember that if the x is on the denominator, then we have to cross multiply and divide by the 0.2. So that means that x is 20 divided by 0.2, which is 100. Okay? So by this probability, there would have been 100 fish in the pond. Okay? So now you can see that 3 out of 15 on your calculator is 0.2, and also 20 out of 100 on your calculator is 0.2. And that's what we want. We want the probability to match. Okay? So that's it. Let's get to work.